In this video, we'll be learning about even and odd functions. We say that a function is even if its graph is symmetric to the y-axis. We say that a function is odd if its graph is symmetric with respect to the origin. Our goal in this video is to learn how to decide when a function is even or odd just by looking at its formula. Let's start by looking at what makes a function even, and we'll do that by looking at a graph of something that is symmetric with respect to the y-axis. When we look at a graph that's symmetric with respect to the y-axis, if we take any point on the graph, if we look across the y-axis, we find a matching point on the other side. Now suppose that what we have here is the graph of a function called f. Let's look at the graph of our function at the x value a. The corresponding point on this graph would be over here. We know that the x-coordinate at this point is a, but what's the corresponding y-coordinate? Remember that when we're graphing functions, the y-coordinate of a point is the corresponding output. So the y-coordinate of this point would be f of a. Since we have symmetry with respect to the y-axis, the y-axis acts as a mirror for us. Our point a, f of a will have a mirror image across the y-axis. Let's try to determine the coordinates of this point. For our blue point, we're a units away from the y-axis. So to get to our green point, we should also go a units away from our y-axis, only this time we're going in the opposite direction. So the x-coordinate for our green point should be negative a. For any point on the graph of our function, we know that the y-coordinate is the output of the function. So the coordinates for this green point would be negative a, f of negative a. Now, because of symmetry, we know that these 2 points here must have the same y value. Therefore, we can conclude that f of negative a equals f of a. We can repeat this idea with a different point. For example, we can start with the x value b. The corresponding point on our graph would have coordinates b, f of b. Now, because of symmetry with respect to the y-axis, this point has a mirror image on the other side of the y-axis here. The question is, what are the coordinates of this point here? To get to our blue point, we go b units out from the y-axis. Therefore, to get to our green point, we also have to go b units out, only in the opposite direction. So the x-coordinate for our second point should be negative b. If negative b is the x-coordinate, then the corresponding y-coordinate would be f of negative b. So our green point here would have coordinates negative b, f of negative b. Now, because of symmetry, these 2 points must have the same y value. Therefore, we can conclude that f of negative b equals f of b. Now, these relationships that we see here hold true no matter what our x value is. So we can conclude that in general, f of negative x is equal to f of x whenever we're looking at a function whose graph is symmetric with respect to the y-axis. This relationship is how we will tell whether a function is even or not. Now let's look at odd functions. Remember, a function is odd if its graph is symmetric with respect to the origin. So let's take a look at such a graph. Remember that a graph is symmetric with respect to the origin. If you take any point, draw a straight line through the origin, you end up with a matching point on the other side. Let's select a point on our graph to see what relationships we can come up with. Let's select an x value a and look at the point on our graph. The coordinates of this point would be a, f of a. Now, because of symmetry, if we take this point, draw a straight line through the origin, we end up with a matching point on the other side. So now the question is, what are the coordinates of this point? Let's actually connect our 2 points with a line that goes through our origin. Now, if we start at the origin and try to get to the blue point, we would have to go over a units and then down f of a units. So if we want to get to our green point from the origin, we have to go left a units and then up f of a units. Now, if we go left a units, our x-coordinate for our green point will be negative a. This means that the coordinates of this point would be -a, comma, f of -a. So now the question is, how are these y coordinates related to each other? Now remember, to get to our blue point, starting from the origin, we go right a units and then down f of a units. Now this amount that we went down by is the same amount that we're going up by to get to our green point. So our two y coordinates, f of -a and f of a, essentially have the same y value, only one of them is positive and the other is negative, because for the blue point we went down by this amount, whereas the green point we went up by that same amount. Since our two y coordinates have opposite signs, we can conclude that f of -a, the y coordinate of the green point, is equal to negative of the y coordinate of the blue point, which is f of a. Now this relationship here will hold true no matter which x value we focus on. So in general, whenever we have symmetry with respect to the origin, we have the relationship that f of -x is equal to negative of f of x. So this relationship here is how we decide whether a function is odd or not. So in this video, we learned the conditions for when a function is even and when a function is odd. In our next video, we'll look at some examples of functions and determine whether they're even, odd, or neither.